Hey again, Copper Canyon Algebra 2. So this is still 9.2, but today, or on this video, I'm going to focus on arc length. Haven't talked about arc length at all since we started talking about 9.2. So here's a couple examples on arc length. First of all, arc length is a simple formula, and what it does is it calculates the length of the arc. So the distance or length of a section of a circle. Key thing, it's only a section. So you know a circumference is the full circle, the length around the full circle. So arc length is really just taking sections of it. Like, oh, I only want a quarter of the section. How much is it around that? You know, you're really just measuring the perimeter around a circle. So idea-wise, quick diagram of arc length. You know, here's a circle. Here is an arc length. This red little section here. We're trying to figure out what that length is. Now here's the thing, we're dealing with circles of different radius, different radii, so we have to kind of keep that into account. So there's a formula for arc length. It's pretty simple. So coming over here to the first example, just some vocabulary, some variables that we need to define here. So S is what they're going to use for the variable for arc length. So when you see S in your formulas, they're saying, hey, that's the arc length value. R, appropriately, R stands for radius, so that should be pretty easy for us. And then this one right here, I tell my students every year it looks like an Easter egg kind of because it looks ovalish and then it's got like these little squiggly lines in it. Appropriate is really right around Easter time, right? But this is actually the Greek letter theta, or the Greek variable, or we use it as a variable quite often for angles. So this is theta, okay? And theta is going to usually measure your angle. So now angle can be anything. It could be, you know, 145 degrees. It could also be measured in radians. Key thing, when you're calculating arc length, you have to use your theta and it has to be in radian measure. You cannot plug a degree measure into the formula for arc length. You will not get the right answer. You've got to make sure you first convert your degrees into radians if it's not already converted. So some things to watch out for. All right, so here's the first example. You might get some pictures, all right? So picture number one, here's a circle, right? And they give us the angle measure on this circle. So this section, the angle section measure here is 50 degrees. Notice I said degrees. And then the radius length here is 9. So they're giving us those two pieces of information. They want us to find the arc length. So just kind of keep in mind, I'm a big fan of color coding here, so we're going to do a little color coding here. Do we know the arc length right now? Obviously not. The question is even asking, find the arc length. We do not know the arc length right now. But theta, remember, theta is our angle. So technically, we're going to get theta from here. But notice I'm not going to actually write it out here in the formula yet, because before we do anything else, we've got to convert that 50 degrees into a radian measure. So here we go, real quick. Going back to the first examples I gave you, so here's 50 degrees and we need to multiply that by, now again, we're converting from degrees into radians, so would we do pi over 180 or 180 over pi? Remember, we're trying to get to radians, so where does that pi go? On the top. So we're going to do pi times 180. Okay, you can type that into your calculator. I like to leave it with the pi on it. So again, I'm not going to get a decimal here. I'm just going to work that out. So if I were to work that out, I would have ended up with 5 pi over 18. Okay, this is going to be my theta. So that's the one I'm going to use inside my formula. Now R, they already gave me my R. It's right here. I don't have to worry about converting anything. Radius is 9 here. So I have the blue value, I have the red value. I just need to plug those two things in and multiply them out. So here we go. I got my 5 pi over 18. So 5 pi over 18 is my radian measure. Again, I would definitely go to decimals here for this. And since we're trying to find arc length, we are actually going to put the pi value in there with it. So we've got that, and we're multiplying by a radius, which is 9. So if you were to type that into your decimals as is, make sure you make this a fraction, 5 pi divided by 18, close it off, times 9. You should get a decimal, and I believe our decimal should have been 17.675. So we're going to round this to decimal places. I'm going to say approximately because it's approximately. So 17.6715. Most of your problems ask you to round to the nearest tenth. So this is going to be, is it going to stay 17.6 or about to 17.7? it's going to bounce up to 17.7 if you're rounding, and this is in inches. So that would be your arc length for that particular situation. Hard thing there was you had to convert the degree to a radian first, because if you did the calculations with 50, totally different answer, wouldn't have even been close. But I bet you that's an option on one of your quizzes, so make sure you're converting. Okay? All right, so that's example 1. Example 2 is a little more wordy. This one was nice because it was a visual. So example 2 is a little tricky, but it's actually pretty easy once you get your calculator part going on. So it says circle has a central angle of 2 pi over 3. It intersects an arc of length 21 inches. What is the radius? So pay attention to what they're asking you for. Also pay attention to what they're giving you. I'm a big fan of color coding because, again, this is why I have you guys use highlighters a lot. You really want to go through the information and say, what do I have and what do I want to find? Okay, so think about this. You already know that this is your formula right here. S equals theta times R. So, S, do you know your arc length? Do they tell you the length of the arc? Circle has a central angle. That's an angle that intersects an arc of length. You already know your arc length. So you know your green value. Your green value in this problem is 21. This is your S value. Okay, it's very important that you go through the information they're giving you and identify it. 21 is your S. That's the green value in the formula that we had up here. Okay, moving on. Going back again, this 2 pi over 3. By now you should start getting these triggers that, oh, it's got a pi on it, it's got a pi on it, it's got to be a radian, right? That is your radian measure. That's your angle, okay? Not your radius, okay? Your angle, your radian angle. So that is your theta in this problem. So you've already got your theta, and it's already converted for you. It's got pi on it. You don't got to convert it. It's already in radians. So this is good to go. So the only thing you're missing is the red value, which is your radius. So thinking about what that means in terms of an equation. Let's put these two values in the original equation and see how we can solve for R. So here we go. S is 21. So we got 21 equals theta. We know theta is the 2 pi over 3 times R. We don't know R. In fact, that's what it says. What is the radius? We don't know it. So this is actually our variable. Okay? So thinking through that, how can we solve for R? You don't have to do anything crazy. I know you guys see fractions and sometimes you freak out, but just don't worry, you've got calculators. How would you undo the math? You want R to be by itself. What's the opposite of multiplying by 2 pi over 3? Opposite of multiplying? Divide it. We're going to do that. And you don't have to worry about how to do that. You just have to worry about, hey, that's what I got to do. So let's divide both sides by this atrocious 2 pi over 3. This whole mess, boom, gone. I got R by itself. You might be looking at this and saying, oh my goodness, what am I going to do with that? You've got a calculator. Desmos, you just had to know that, hey, I got to divide that. You can put it into Desmos. 21 divided by 2 pi over 3. Remember, we're including the pi on the arc length calculations because we actually want a length. We want to know exactly how long it is. We don't want the pi left in the answer. We want to work it out in there. So if I just go to my Desmos and type that in, I should end up with, dun, 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 I'm getting 10.026. So in terms of radius, your radius length here, approximately, we're going to change this to approximately because we're going to round. I got 10 for sure. Okay, now it says 10.026. We're going to round to the nearest tenth. That's the first decimal. So it's 0.02. If it's 0.02, it's going to stay 0. So this is really approximately 10 inches because it's going to stay 0. Okay, so you might have to do a little rounding, but I always say when you're doing a multiple choice test, you can usually find those pretty fast. All right, good luck. That's arc length examples. Hope it helped.